Hi guys, just moving on from previous stuff on being able to look at the equation of a line and plot it onto our set of axes, just using the gradient intercept method. Now we're going to have a look at a line that's already there and see if we can use the gradient intercept method to get the equation of the line from it. I'd really recommend having something like the Desmos.com, the Desmos graphing calculator handy. It's a little bit of software you can use. Fantastic. You can enter the equation in that you're looking at, and it'll plot it for you straight away. So anything you want to check, you check your work straight away on that. It's a gorgeous little thing. Cool. So let's see how we go. We're really looking at this graph. A couple of things we need to know. We're looking at y equals mx plus c. And really, we're doing our best to figure out that and that as values. And we know that m is a measure of gradient. It's a number. It's going to tell you how steep that line is. And this is our y-intercept. And that's going to be where this line cuts through the y-axis. So really easy to find that one. Well, I think anyway. So let's go through it. Let's just start with the easy thing. Let's populate that little bit there with a number. So look along here. Where does it actually cross through the y-intercept? Bang. Oh, it's exactly at 1, positive 1. I can now write, oh, okay, that should be y equals, I'll leave some space, something x plus 1. Cool, part done. If you're in an exam situation, that's already going to earn you a mark having that. Okay. The next thing we will need to check out then is actually what is this gradient? How steep is it? What's the slope? As usual, we're going to go about checking out, steps between known points. Okay. So this one here, we're looking at for every step across, how far up does it have to go? So let's go. Always do my ups first. So there's up 1 and across 1. From known coordinate to known coordinate, these are coordinate locations. It goes up 1, across 1. Check it out. The next step from known coordinate locations, up 1, across 1. And it keeps going, up 1, across 1. In fact, gradient is always about if you want to write it, it's the up-down movement over the across movement. And in this case, it's going up 1, across 1, or 1 over 1 equals 1. So we know our gradient is 1. So we've got 1x. And I could put a number 1 in front, but we know actually not that important actually to have the 1. We know we don't have to write it when there's only 1 of something. So we can just write it as y equals x plus 1. That's our slope and gradient. Okay, we'll try another one. Try another one fairly quickly. I'll plot one on there for you. So I might just plot this one in green.